6:43, we can keep going. So let's take a look at Chapter 2. All right, so talk about defense mechanisms. So you can limit users' access to parts of the app, like you'll have an administration console that normal users shouldn't get to, that sort of thing. You can limit user input. So if you don't want them performing cross-site scripting, you'll stop them from putting up less than signs and greater than signs, which are used in cross-site scripting attacks. You can frustrate attackers. You can make it so it's difficult and you waste their time. For one thing is to put them in a tar pit. If people send malicious content, you start responding to them really slowly so that they can't continue their attack. And you can have administrative monitoring, where you just monitor the network traffic and the behavior of your app to see if something bad is happening. This is the modern technique. This is network security monitoring. We've got a class in it coming up on Saturday, where you watch for malicious activity on your network and respond to it. All these are good defenses. So to handle user access, you have to authenticate people so you know who they are. Then you have to remember who they are. After they make a request and log in, you have to put something like a cookie on there so you remember who they are. That's session management. And then you have access control, where when they try to do things on your server, like access data, you check to make sure that they have authenticated as the right user and they really should have the privilege of seeing that data. And this is what I mentioned before in the news section. This is what fails very often with APIs. Application Programming Interfaces repeatedly fail to enforce access control for all the methods. So attackers just try all the methods, just like you try every door in an apartment building until you find one that's not locked. You find one of those requests that doesn't perform a access control, and now you can get data that you shouldn't have been able to get. So authentication is typically a username and password. These days on a phone, it might be your face or a fingerprint or something, but you have some kind of identification, which is your username, claiming to be somebody, and then some kind of authentication, which is proving it by knowing something that only that person would know, or having a common access card or something, some kind of proof. So what's better is to have multi-stage login or additional credentials where you have not only a password, but also a hardware token you carry or something like that, or a biometric. That's two-factor authentication, which is much better. Smart cards and client certificates are very good. And there's a lot of other issues here, like how do new users register? How do people get in if they lose their password? This is often the weak spot, because it's too expensive to pay for help desk people to really talk to them or make them actually drive to your office or something. So typically they just have to answer some foolish question. This is how Sarah Palin got hacked years ago. She started doing company business from a Yahoo account, and Yahoo password reset just asked her, what city did you meet your husband in? So somebody just Googled to find out what high school she went to, and that was it. So you could easily get in her account. And that's usually what happens with account recovery. The password reset is often the weak spot. So there's the login function. You put in username and password. Then you put in, there's rules on this. This must be at least 8 characters. This must be at least 8 characters, that sort of thing. Typical login page. All right, so usernames are often very predictable. The passwords can often be guessed. People that try often learn you can pretty much guess what people are going to use for a password a good fraction of the time if you know them. And even if you don't, a lot of people use the same common passwords. And there are often logic defects where you can skip over a page, or where there was also an attack that was going around a few years ago where you would call like Yahoo and talk to them, and they would give you like the first 4 digits of some number if you knew like the address, and someone else would give you some more, and you could use like call 3 different companies and you get a little bit of information, and that was enough to convince another company to let you in. It's the kind of thing, because they all used different relatively common things like your address, your phone number, your social security number to prove who you were. All right, so session management is some way to remember the fact that you've logged in. You've logged in, now I know who you are, and as you continue to traverse through the website, going place to place, I remember who you are somehow. That's session management. So typically you do it with a cookie, and the cookie is stored on your machine, and every time you make another request to the same server, your machine resends the cookie up. So I keep bouncing this cookie down to the user, back to the server, down to the user, back to the server, and that cookie is what I use to identify them. Now, it would be good if the cookie only lasted for a certain amount of time and then expired. So you can't just keep using it forever. And as I mentioned before, in my tests, I found a lot of websites where it never expired. All All right, so common problems. Sometimes the cookies are predictable. They're not random, so I can guess somebody else's cookie, then I get in as them, or the tokens are poorly handled. This was a huge problem until about 8 years ago. Many websites would log in with HTTPS, then they would switch to HTTP. Gmail did this. I got hacked at DEF CON, the famous hacker conference. I was on the wall of sheep. I went there and logged into my Gmail. I didn't know that the session cookie was sent unencrypted, and there was a guy there demonstrating his tool, which was hamster and ferret, and he got in my Gmail. So I spent the next year doing that everywhere. This was a common practice, and Google fixed it by switching to 100% HTTPS, and over the next few years, pretty much everybody else did. So now almost every website uses HTTPS all the time, and that helps a lot. That means nobody, even sitting next to you in a coffee house, can just steal your cookie off the wire. They can steal your cookie, though, by attacking your web browser in other ways, and we're going to do it in this class with attacks like cross-site scripting. But they can't just steal it by sniffing the wireless traffic from your device anymore, although you could. About 8 years ago, you could do that for almost every website. So each request has to be permitted or denied, and there are often flawed logic flaws and logic errors and false assumptions in this. But here's the point. You must be authorized to access this page, log in, and then you can't get in until you've logged in. Input validation is the most common solution. Must have 4 characters here. This must be a valid email address. This phone number must contain only numbers. You have rules like this. The problem is input validation is often enforced by scripts on the client side, which the user can avoid. And often input validation does not really think of all the things that can go wrong, so that even obeying these rules doesn't really stop all attacks. So like blog posts can have arbitrary text. Your cookies can just have any kind of text in there. You can have form fields that are invisible. They're in the source code and sent back to the server, but they're not visible to the user. And parameters go in the query, in the URL, in the query string. And there's other header fields. All these things are areas of data that are sent to a server when you use the web, and all of them can contain malicious traffic. So this is the most common thing people do, called blacklisting. I think now they call this deny listing. This is the least effective method. You try to enumerate all the bad content and block it. So you try to block the word select. But then if they change some of the words to lowercase, it might not match your filter anymore, and it will get through. And this is the kind of thing you have. It tries to have a list of all the known attacks and block that content, but all the attacker has to do is make something that's not on your list, which can often be as simple as adding spaces in it or something like that. So that's the problem here. This is a common cross-site scripting attack here, and the trick here is you add a null byte at the start. So what will happen is the web server will still process it, but the web application firewall, which is written in C, will interpret this as the end of the string and not see it. And this is the problem with deny listing. Deny listing is generally ineffective, just like blocking spam email by looking for keywords is ineffective, because all the attacker has to do is change the attack a little bit, and it will no longer match your list of bad things. So the other one is, I think, called allow listing is the modern word for it. It used to be called whitelisting. This is where you only accept things that you know are good. You don't try to list all the bad things. Instead, you list the good things, and you deny anything that doesn't match. This is much safer, because it's much easier to just say what's good. And the simplest case is, I think, F-Secure, and for that matter, the Macintosh. If you buy a Macintosh and you do not change the security settings, it will only run software that you get from the Apple Store. And if you get an iPhone, it will only run software that you get from the official Apple Store. And that's known good. You can only use things that have passed a test and you know they're good. And that is extremely effective. There's essentially no malware on the iPhone, and there's very little malware on the Mac. Whereas on a PC and Android, there's a lot of malware because you can put stuff from anywhere. And so if you can put up with only running approved stuff, it's much cleaner. And the same thing's true of your web app. If you only accept code input that you know is good, that's much easier, much safer. But this is a very common practice that is extremely dangerous, and it's going to be at the heart of most of the attacks we do. What they do is you try to remove the harmful part of input. So you do HTML encoding, a space becomes %20, because 20 is hexadecimal for 32, that's the code for a space. Every character has a hexadecimal code, and you can HTML encode it, but and do other things to try to prevent special characters from being interpreted as special characters at the other end, but it's pretty easy to overcome this. So sanitization is where you get input that looks fishy, and instead of rejecting it, you try to clean it up and then continue to use it. That's the problem. That's just a challenge to the hacker now. It would be a lot safer to just, as soon as anything looks fishy, reject it and say, nope, try again. That would be safer, but a lot of websites do not do that. They try to clean up the possibly dangerous data and continue using it. All right, so safe data handling is what you want. You write code that can't be fooled by malicious data. In SQL, you can use parameterized queries. With paired statements, parameterized queries completely prevent SQL injection. And we'll have projects where you do this in detail. You see how it works. But parameterized queries have a clearly defined separation in the code between data and commands. So there is no possible way a data from the user can be misunderstood as a command anymore. That's what happens in SQL injection. You have a string with data from the user and commands all mixed in the same line, and if the user puts in something like an apostrophe, they can trick the code into executing part of their data as a command. But parameterized queries prevent that, and they're, as far as anybody can tell, they're 100% effective. And there are other ways to do this. You can avoid command injection by not passing user input to a UIOS command line. So there are safer ways to write your code where it will not be as vulnerable. That's safe data handling. Then there's semantic checks, where you just validate things in context, decide if it looks good. Does the account number look good? Is it the right account number? And so on. You do appropriate checks whenever data comes in to make sure that data looks reasonable. So data coming from the user is bad or untrusted. We often assume the server-side app is good and trusted. And then you have, but the problem is it goes in one server and then to another server, it goes in your web server, then it goes to a database server, then it goes to some other server to handle the financial transaction, all written in different languages, all running on different systems, and each one of them is getting data from another one. So it's very common that the flaw is between servers. Each server is acting correctly, but the first server is putting out data which is misunderstood by the next server. It's sort of like you have instructions in English, then converted to Japanese, then converted to Spanish, and then the end result is wrong, but no one person regards them as having made the mistake. Anyway, that's the problem. Harmless data at one stage may be harmful at another stage. So you have the recommended procedure is boundary validation. You have trust boundaries. Let me see, maybe I got to close the door, or we'll see if these guys wander away. All right. Anyway, reminds me, yeah, I'll give you guys a break pretty soon, but I think we'll finish this before then. All right, so anyway, so you have a trusted zone and an untrusted zone, and you clean the data that passes the boundary. You check it. This is what you have to do, and it becomes more complicated than it would have been. So the input might be malicious, and you perform data validation at each trust boundary. So here, you have a user going to the application server, and then to the database, and then over to a SOAP service, which is doing something, processing data in a format. And so you have data coming here, then you have a SQL query going here, and so you hopefully clean the SQL here, then you encode XML meta characters because SOAP uses XML, and you don't want to let the user put in extra XML tags, so you clean those out of here, and then when you go back here to display account details, you sanitize the output so that the data coming back here cannot have anything like script tags in it. So this is what you do. You have general checks of the login coming in to make sure the username looks like a username, the password looks like a password. These are the various steps. Every time you move from one area to another, you check the data to make sure it is not malicious. And this is what SOAP looks like. SOAP looks like a web request, but it's just a little bit different to send a format to send data. All right, so the app gets username, allows only good characters, limits the length. Then it has a SQL query, and you escape dangerous characters. You remove things like apostrophes and such. Then here, the login succeeds, so it passes data from users to a SOAP service to do something else like fetch data about that user from the server, and you block these characters to avoid SOAP injection, which we'll do in the projects. And then when it sends the account information back to them, it does something like HTML encoding so that it will not allow scripts to be sent back to the user. So that's a simple example of how you would do it. And so filtering often fails. If you try to remove this string, the attacker can just send this. Now, when your filter removes the script in the middle, what's left will be script. So one pass of filtering is not enough to stop that attack. And if the app first removes, you're trying to avoid directory traversal. / will move to the directory above where you are in a command line environment. So in early days, you could just put it in a URL. You could go to a web browser, and up here where you have kahoot.it, you could just go here and you could put .. / and then .. and then go to like Windows System 32 CMD.exe. You could just type a path that ended in CMD and you get a command prompt right here in the browser and take over the server. This was true of early versions of Microsoft's web server IIS. So this is directory traversal. So you don't want to let people do this. So one thing to do would be to stop .. in file names that are coming in. And you could try that. If your app first removes .. and then removes .. I send it this. You remove the .. and there is no .. So anyway, that's the, first you look for .. and there is no .. Then you remove .. which takes this off, and now what's left is .. So even though you had a filter, I can just send attacks that punch through your filter. That's the problem with deny listing. So another one was canonicalization. When you send anything up, you can see this, by the way, if you go to a URL up here. If I go here, I can put in data. If I put in a space, .html, it changes to %20.html. Okay, that's what a space is. Whenever anything is put in a URL, it is URL encoded, a percent and then 2 digits to express the hexadecimal value of that character. That's called canonicalization, and it's a way to sanitize data. So an apostrophe is %27, percent is %25. So to block apostrophes, the app will filter %27. This is another mistake made by Microsoft Web Server IIS. It decoded data twice from canonicalization. So you could send this %2527. And it would decode the %25, which turns into a percent, and that would turn into %27, and that would decode to an apostrophe. So you could sneak an apostrophe in this way, and an apostrophe is what you use for SQL injection. So you'd have a SQL injection filter that tries to stop apostrophes, but you'd put in this, which is not an apostrophe, and it would be interpreted as an apostrophe after the decanonicalization. So that's the kind of thing that happens. That's why, deny listing is for the birds. It just is a challenge for the attacker to find a more clever way to encode the data that will faster your filter. So you got errors. If things happen on your server, you should figure out what to do about it. You should have audit logs, and you should be alerting administrators and reacting to attacks. One good thing you should do is just cancel the session of anybody that's sending up funny data. It's anybody that fails too many logins or sends any funny characters, just cancel their account. See? You make them wait for an hour before they can try again. They're not a valid user, they're an attacker. Don't let them keep coming in. So another thing you have is inappropriate error messages. A lot of websites, if you put in the wrong data, they will just crash and print a bunch of useful error messages telling you versions of the software and such. This is a security vulnerability of information disclosure. I can learn about your web server. There's a time, after I did all those colleges years ago, I tried testing political parties. I went to the Democrats' web server and see what I could find. I went to the Republican National Committee's web server. I put an apostrophe in the URL, and the whole page turned into screaming red ASP error messages. I said, I think I'm going to quit poking around here. I think these guys are going to get mad at me. But it couldn't handle anything, and it dumped out all kinds of information I wasn't supposed to know. By the way, I later found out that's not legal. I thought it was legal what I was doing, but the Computer Fraud and Abuse Act is really, it ruins all your fun. You're not allowed to do anything weird like that. It's technically illegal, so be warned. Anyway, so audit logs should be recording login success and failure, password changes, transactions, access attempts that are blocked. You should be recording those so you know if this IP address is doing a lot of things that get blocked. That's a clue that they're malicious. Requests containing attack strings. And for the highest security, logging every request in full is good, although that slows down your server. I put up, years ago for this class, I had a page where you could perform various attacks like SQL injection, And I thought you could only do a couple things, like change the data, and somebody put up whole images and defaced my server. And I'm like, how did you do that? And he said, you're so smart, figure it out. And I said, well, I tried putting on logging, and he did it again. I still couldn't do it. I put it in defense, he punched through it. I had to go through 3 cycles of that before I learned how to turn on Apache forensic logging. Apache forensic logging will log every request in full, and I could finally see what he was doing. But you don't do that on production servers because it slows down your server. But I learned a lot. I've had often attackers attack me, and it's educational. Anyway, so your logs will have to have time, and they're often going to have things like cookies and other sensitive data, so you should protect your logs so they're not visible to the whole world, and of course, so the attackers cannot erase them, because they will often try to erase the logs to hide the tracks. So you should put them on another system that only accepts update messages, and flush them to write once media is a good plan, so that they can't be erased. So when bad things are happening, you should be alerting administrators, like technical flaws, like a lot of requests from the same IP address, business anomalies, like large funds being transferred, requests containing known attack strings, and that sort of thing. There's plenty of ways to detect things that are suspicious, either from a technological or a business perspective. So firewalls, normal firewalls just block data by things like port number, and known web firewalls can detect generic attacks like SQL injection, but not subtle ones that depend on your the details of your app. So let's see, I have a question. I remember writing an app, we took a file name, we wanted to prevent directory traversal, we wrote a regex filter. Later on, the app wouldn't work. That's right. Yep, your filter was too complicated and it blocked good traffic. That's another thing that can happen. So attackers probe for vulnerabilities. They send many similar requests. This is what happens when they use vulnerability scanners. It will send thousands of requests with punctuation marks, all of them trying to find SQL injections. So it's pretty obvious and easy to detect. So one thing you can do is respond increasingly slowly to requests if you get too many requests or requests with junk in them from the same IP address. The management interface, like here's PHP Nuke, which I learned about in the first Pentagon bug bounty program. The third one's coming up. I was in the first one, and I said, well, I'll see what I can do, and everything was running, I think it was it PHP Nuke? Yeah, it was PHP Nuke on Windows, I think, and I didn't know anything about it. And I'm like, what is this garbage? I didn't find any vulnerabilities, but I ran a vuln scanner. It told me there were 100 vulnerabilities, all of them false positives. But anyway, other people made money from them, but not me. But anyway, your application will have an administrator interface, and that's a dangerous high-value target. You don't want to let random people get there. Typically, you should have that thing limited to only certain IP addresses, or at least behind two-factor authentication to get to the administration panel. So you can do, if it has weak authentication, you can defeat it. Sometimes you can do things without high privileges. Years ago, I found there's an Apache middleware product whose name I've forgotten, which is software to connect two systems. And I was reviewing the DEF CON talks that year, and there was a talk about this product. And so I just searched on the web, and I found a server of this type running in Texas, processing checks. It was printing checks for people, and all the checks, you didn't have to log in at all. There was a page that showed all the check data going by. And you could even modify the check data going by without logging in. And I hunted down the people that did it. It turned out to be a Canadian medical insurance company that had hired a Texas company to print their checks. And I even found the forum posts from their administrator, because asked from 2 years earlier saying, I can't figure out how to password protect this page. How do you do it? And not getting a good answer. So I contacted them, and they finally said, you got to put that behind a VPN or something, which is what they did. But anyway, that's one of these things. You have an administrative panel that lets people do things without logging in. Then you got to protect it. So let's look at another Kahoot, and that'll be it for the lecture today. I'll demonstrate some projects after we take a break. And I've sort of fouled up this page by sticking junk up here. And notice they didn't kick me out or anything, which might have been the wiser thing to do, because here I am sending funny data to Kahoot. But anyway, here are my favorites. And here, all right. Can't get in? You have the right number? Kahoot.it? And this number, 332-7187? Yeah, good. Good. I'll give it a few more seconds. All right. All right, so what does login do? Yeah, that's authentication, proving who you are. All right, how does a website remember who you are? All right, yep, that's called session management. You somehow have to remember who this person is as they do various things on your website. All right, if you write code that can't be fooled by malicious data, what's that? Okay, that is safe data handling. These other things are weaker defenses, but safe data handling is writing code that can't be fooled. That's the strongest way to protect your data. That's why training your developers to write more secure code is probably the best thing you can do. But the easiest thing for management to do is just buy a device like a web application firewall. They know how much it costs, but it's not as strong a defense. But it's easier for them to be sure it's been done. All right, and so what process removes malicious parts of input and then uses the remaining portion? That's sanitization. It seems like a really bad idea, but it's very commonly done. All right. All right, one last. They'll have to tell me who they are if they want their points. And DAZ, and unless those are actually initials, my grader won't be able to figure out who you are. And geez, that's a real looking name. All right. So, oh good, I see a name coming in the chat. Let me stop the recording.